Good evening, guys. Check, check, check. Good evening, guys. So, I'd like to indulge my penchant for the science fiction tonight. I hope you guys enjoy it too. I'm fascinated by, well, both ends of the spectrum. I enjoy looking into the origins of our consciousness and those features about us that really, really make us different than the animals. And probably in a similar vein, I enjoy the brilliant speculators of our future, which is what tonight's video is going to be centered around. The Kardashev scale is a scale used to define the technological advancements of civilizations proposed by Russian astrophysicist Nikolai Kardashev. The scale has originally, had three categories. Type 1 was also called a planetary civilization, and it's defined by their ability to store all of the energy which reaches its planet from its parent star. So a type 2 is, as you can imagine, scaled up. It's called a stellar civilization, and they're defined by their ability to harness the total energy of its planet's parent star. And an example of this would be a Dyson sphere, which we'll get into in just a little bit. So, the last of the typical ones, the traditional definition of the scale is a type 3, which is a galactic civilization. It's where, as you can imagine, again, this is a civilization that is so advanced and has obviously conquered the ability to break the light barrier. Or else it would at least be tens of millions of years in the making. It's crazy to think about this, but it's actually able to control the energy of an entire galaxy. It's a hypothetical scale, but nonetheless, it's very, very thought-provoking. So I'm going to jump right into just exploring in a little more detail what these actually mean. I read this book years ago by Michio Kaku called Physics of the Impossible, and in this book is where I originally heard about this scale. And it's just, to me, it's like we, as a civilization, I was just listening to Terrence McKenna earlier today, and for as much radical speculation he does, he is a very learned person. Is that how you say he was talking about the analogy of our own lives scaled up to our entire species, and that old adage that if you don't define your own narrative in your life, you're going to become a bit player. You're bound. I would say it's a pretty solid, pretty irrefutable rule that you're going to be a bit player in someone else's story, someone else's drama. And that goes for our entire human species. In the case that we ever meet another alien race, if we don't have a clearly defined goal of what it is what our purpose is, and where we're going, and what we intend to do. And kind of like Star Trek, you can have a vague, you can leave the precise you can leave the goal vaguely defined as long as you parameterize it correctly. So the goal for them was just to learn from and meet new alien species, and all interesting objects, really, for that matter, in the process of exploring. Yet they had the prime directive, which was, am I getting confused? But they had rules that established how to act and what not to do, and certain rules and boundaries that could not be transgressed. I think theorizing about these types of future scenarios is important for that reason, and it's also important, I guess if I wasn't too specific there, it's for the reason that if we have a true encounter with an alien race, we aren't led astray, because Lord knows, for all the good that we do, we're very much capable of evil and steering people astray and not necessarily being forthright. So I don't think it's too much of a stretch to imagine a violent, malintentioned alien race. So let's I guess I gotta explain the imagination. So if we were prepared, we're very unified in our ideas about where it is we're going as a species. And I think, of course, right now our main goal should be to eradicate absolute poverty. So once we're there, what do we do with ourselves? You know, if we ever reach an instance such as Star Trek, where nobody necessarily has to have a job, and people engage in science and other forms of self-improvement through challenging their skills. If we ever reached that status, I think it could be easy to be led astray, and for all we know, there could be massive, epic intergalactic battles, and we'd be sucked into it, and I don't know, I guess that doesn't make too much sense, because we'd just be a bit player. But nonetheless, I think it's profound to think about the fact that we are one. We have the possibility of developing, literally at this point, unimaginable technology. And if we don't have moral constraints on the use of that, as good as the intentions of using it might be, we could cause chaos and do irrevocable damage that we wouldn't want. So I think it's good to have discipline and a sense of where we're going, and that's what exploring this type of these ideas, these futuristic ideas in science fiction, really has its value. And it's it's the first tentative ideas of science are always in philosophy, and the first inklings of great philosophic movements can be found in pure, intense, passionate expressions of art, whether song or music or art, paintings, drawings, such. And I love evoking our imagination. So we've reached a turning point in our society. According to the renowned theoretical physicist Michio Kaku, the next 100 years of science will determine whether we perish or thrive. Will we remain a Type 0 civilization, or will we advance and make our way into the stars? Experts assert that as a civilization grows larger, becomes more advanced, its energy demands will increase rapidly due to its population growth and the energy requirements of its various technological inventions, machines. With this in mind, the Kardashev scale was developed as a way of measuring a civilization's technological advancement based on how much usable energy it has at its disposal. To expand on the Type 1, so I didn't mention Type 0 yet, so I want to. These scales are actually designed to be in accordance with the literal amount of energy in watts used. So a Type 1 would be 10 to the 16th watts, 10 with 15 zeros after it. Type 2 would be another 10 orders of magnitude, so 10 with 25 zeros on the end of that. And a Type 3 would be yet another 10 orders of magnitude, so that would be a Type 3 would be 10 to the 36 watts, or 10 with 35 zeros after it. And just for good measure and thought experiments, people have actually extended it to a Type 4 and a Type 5. Type 4 was just another, again, 10 to the 46 watts. Type 5, though, was all the available energy in the entire universe, but we didn't stop there. We said in all universes, in all time, in all timelines. So these additions consider both energy access as well as the amount of knowledge a civilization has access to. So right now we haven't even reached this scale yet. We still sustain our energy needs from dead plants and animals, dinosaurs, fossil fuel, and an increasing smattering of alternative energies. But we have a long way to go before being promoted to Type 1. Kaku tends to believe that all things taken into consideration, we will actually really reach a Type 1 in maybe at most 200 years. So, when you look back, that's actually really, really quick. I think it's probably, yeah, I guess that's realistic given the rate of transformation, but it seems optimistic if you think about 200 years ago, 1818, we were I guess roughly we were just beginning to use the steam engine. Let's see, when was steam engine? A brief history would be 1st century AD. Someone had thought to do it. 1125, 15, 1601. There's a percolator. 1615. Louis the 13th publishes a book. 1818. Okay. All right. So 1815. 1827. So 1801, they were learning to make it pretty efficient with railroads. Yeah, I don't know, to me that's just fascinating that just 200 years ago we were not using electricity at all. We were using it for kind of like whimsical demonstrations. Didn't have any combustible engines. Although I have to know that. Combustible engine. When was that? Let's see. First hybrid vehicle. 1877, Nicholas Otto patents a 4-stroke internal combustion engine. Alright, well, so, yeah, we're advancing at a very rapid rate. But yeah, nonetheless, I think I'm trying to tie this into or evolving into a type 1. Let's see. Well, I suppose the type 2, I'll elaborate on how long it takes to get there. We theorize that type 2 might take us a few thousand years. Type 3 might take anywhere from 100,000 to 1,000,000 years to get. So that's those epic scales like the like Dune and what's Isaac Asimov's famous one? It's probably right in front of me. The Foundation saga, where they discuss civilizations, futuristic, very advanced civilizations evolving over thousands of years. So Carl Sagan actually suggested defining intermediate values. And based on the actual kind of logarithmic scale between the different energy usage or power usage, we would apparently be about a 0.7 at this moment. So let's talk about just what a type 1 would mean exactly. And well, what would that look like? I guess a type 1, that would be the Dyson sphere. There's a lot of images and ideas of how to harness, regarding how we would go about harnessing the sun's light and energy. Dyson sphere would be something like and Channel Isaac Arthur has a lot of actually quite a few really quality elaborate videos with good graphics and all that, explaining this in a more scientific manner. But it could be anywhere from a series of kind of like a fragmented sphere enveloping the sun at a distance of a planet, So maybe something like anywhere from 50 to 200 million miles away from the sun. And it would be able to harness all of the, pretty much a significant portion of the sun's output, which would, of course, in relation to other solar systems, observations of that star, it would very significantly decrease the light, the actual photons emitted from that star. And yeah, it's one way to maybe detect that. Another of that type of civilization that maybe hasn't reached out to other stars, but yet is advanced enough to build megastructures that would literally encompass the entire sphere of the star. And it would be such a massive, massive scale. It's hard to even fathom because, I mean, the Earth is so large. That's hard to wrap your head around, the size of the Earth that we're on right now, let alone the sun and, the larger planets like Jupiter. But imagine an actual series of constructed objects that have enough volume to encompass the entire sphere of not just the sun's local environment, but a sphere at a radius literally thousands of times that of the sun. So it'd be like, try to imagine the sun expanded, and just imagine the surface area. Even if it was fragmented, you would have on that, you'd be able to support trillions and trillions of individuals with that. So you could imagine that you would have to, you would have to be incredibly advanced to be able to construct something that large. But at the same time, you would have to, at the same time, you'd have access to that much energy. I think I heard some figure before, like, if we were able to harness 100% of the sun's energy that hits just the Earth, which is just a pinpoint fraction of the total sun's output, for one day, we would be able to power our civilization for 1,000 years or some extraordinary number such as that. So how else what other clues would we have to know that maybe perhaps we're observing the star of a type 1, 2, or, well, I guess not 3, because that wouldn't be localized to just a star at that point. In 2015, a study of galactic mid-infrared emissions came to the conclusion that the Kardashev Type 3 civilizations are either very rare or do not exist in the local universe. On October 14th, 2015, the detection of an unusual light curve for star KIC, the elegantly, very creatively named 8462852. I like how they added that 2 at the end, really makes it stick in your memory. Raised the speculation that a Dyson sphere, or a type 2, I fucked up, guys. I got my type 1 and 2 mixed up. So when I was talking about Dyson sphere just then, for the past 10 minutes, I've been talking about a type 2 civilization. Alright, they were just, sorry to make it anticlimactic, but they were just talking about SETI trying to search for a type 2, and an initial radio reconnaissance of that star, however, found no evidence. Yeah, I think what it was some abnormal dimming of the stars that they think might be due to it wasn't a sharp dimming like that of a planet would cause, but it was in fact more of a diffuse dimming that they think might have come from an asteroid, a very dense but large asteroid cloud, perhaps blown up, a imploded planet that still maintained its orbit around the sun, but was spread out to maybe encompass a third of the distance of its orbit, of the circumference of its orbit. So a Type 1, a large-scale application of fusion power. So we got to remember not just size, but probably more importantly, it's the actual power, energy usage scale. And that is defining our civilization. So let's see. According to mass energy equivalence, Type 1 implies the conversion of about 2 grams of matter to energy per second. So they're talking about the rate at which we could create energy. Type 1 implies the conversion of about 2 kilograms of matter to energy per second, and equivalent energy release could theoretically be achieved by fusing approximately 280 grams of hydrogen into helium per second. A rate roughly equivalent to 8.9 to the 10 times 10 to the 9th kilograms. Wow, okay. So, if they're talking about using fusion to fuse hydrogen atoms into helium atoms, relative to the amount of water in our ocean, the amount of hydrogen that we have in our ocean, we could sustain life to across geological timescales, which would mean millions and millions of years. And it's amazing that you could even consider that, like the possibility of us actually fusing so much hydrogen that we would start using a significant portion of the amount of water we have on our planet, which of course, at that rate, at that point of technological advancement, we wouldn't even need the water on our planets anymore. We would no doubt have the advanced rocketry and other, fusion propulsion, I'm sure, to go and corral up some asteroids or even some large swaths of nets that might be able to pick up kind of scoop up nebulous clouds of hydrogen gas. That'd be cool. So antimatter in large quantities would have a mechanism to produce power on a scale of several magnitudes above our current level of technology. So, in antimatter-matter collisions, the entire rest mass of the particles is converted to radiant energy. So, their energy density is about 4 or orders of magnitude greater than that from using nuclear fission, and about 2 orders of magnitude greater than the best, purest possible yield from fusion. The reaction of 1 kilogram of antimatter with 1 kilogram of matter would produce 1 to the 180 petajoules of energy. So some of the more interesting things that we would be able to do is harness the actual weather patterns of the entire Earth. We'd be able to affect climate. I don't know how. Weather is very precarious and very chaotic, literally chaotic, scientifically chaotic. God, we could control volcanoes, earthquakes, the weather, obviously ocean currents. Yeah, it would be amazing. What type 1 civilizations can do? Yeah, type 2 can harness the power of an entire star. That would be where a Dyson sphere comes into play. And what could we do with that? Yeah, at that point you would be... God, there would just be so much energy there. You could start to harness actual planets for their raw materials, such as all the gas giants for their gas for fusion reactions. Yeah, pretty much you're guaranteed to be immortal as a species, at least until the universe thins out and cools down, which is a whole nother topic I'd like to talk about and make it less rambly like this one is, but less rambly than this one is. It's fascinating that well, I guess that would be something that a type 3 civilization would be capable of, would be to harness black holes, the energy of black holes, because at that point, well, let's see if they mention anything about that in my notes here. Type 2 civilizations. Okay. Yeah, and a type 1 would just be, I mean, you'd be able to harness all the planetary energy. using solar cells, solar power, wind, hydroelectric, tidal, volcanic, tectonic energy, maybe. And type 2, perhaps a more exotic means to generate usable energy would be to feed a stellar mass into a black hole and collect the photons emitted by the accretion disk. Less exotic would be simply to capture photons already escaping from an existing accretion disk. Let's see. If I go into the Wikipedia site and click around a little bit, let's see what we can find. Okay. Let's see, Penrose process. So you could extract energy from a rotating black hole using this process theorized by Roger Penrose, a famous physicist, or called the Penrose process. That extraction is made possible because the rotational energy of the black hole is located not inside the event horizon, but on the outside of it, in a region called the Kerr spacetime, and a region of the Kerr spacetime called the ergosphere. What's the ergosphere? The ergosphere touches the event horizon at the poles of a rotating black hole and extends to a greater radius of the equator, at the equator. The equatorial, at the equator, with a low spin of the central mass, the shape of the ergosphere can be approximated by an oblate spheroid, while with higher spins it resembles more of a pumpkin shape, kind of like two circles, the outline of a Venn diagram, two circles not fully whatever that was, assimilated. So, a region in which, the ergosphere is a region in which a particle is necessarily propelled in locomotive concurrence with the rotating space-time. All objects in the ergosphere become dragged by a rotating spacetime. In the process, a lump of matter enters into the ergosphere of the black hole, and once it enters the ergosphere, it's forcibly split into two parts. The moment of the two pieces of matter, the momentum, sorry, I thought someone fucked up. The two pieces of matter, when they separate, can be arranged so that one piece escapes from the black hole it escapes to infinity, whilst the other falls past the event horizon into the black hole. With careful arrangement, the escaping piece of matter can be made to have greater mass energy than the original piece of matter, and the infalling piece has negative mass energy. Although momentum is conserved, the effect is that more energy can be extracted than was originally provided, the difference being provided by the black hole itself. In summary, the process results in a slight decrease in the angular momentum of the black hole, which corresponds to a transference of energy to the matter. So, whatever negative mass energy is, I guess, so if you're accurate enough to ride that line and break apart right at the right moment, then as a what would it be, as a phenomenon, as a feature of that local area in space-time around the black hole, as a characteristic of the black hole's behavior, if you tapped into that at the exact right time, the black hole would do I understand that right? I probably don't, because it sounds like something quantum ASMR might be able to help me with at some point. Escapes into infinity. Whilst the other falls past the event horizon into the black hole. Yeah, it just says it can be arranged to have greater mass energy than the original piece of matter. I guess it has something to do with having its mass, like cutting it in half, halving its mass, and the fact that you're sacrificing half of the mass and ejecting the other half with, I don't know, 4 times the momentum or the velocity, acceleration the velocity that it originally had, thereby doubling the momentum. That's the most sense I can make out of it, and it probably isn't even sensical. Oh boy. Starlifting is a process where advanced civilizations could remove a substantial portion of the star's matter in controlled form. And as you can hear, my voice is starting to give out a little bit, so before it gets raspy, and maybe I'll just switch to whispering. I want to at least mention Type 3 civilizations. Because, I don't want to that's why I deleted a lot of my old videos, because they were very, very raspy. So, Type 3 might be using the same techniques as Type 2, but just applying them on a larger scale to most of the stars in a given galaxy. supermassive black holes that, of course, are located at the centers of galaxies. White holes, if they exist, theoretically could provide large amounts of energy from collecting the matter propelling outwards. So a white hole, what is a white hole? It's not a bleached black hole. I'm sorry, I stumbled across an anal bleaching YouTube channel the other day. It was very funny how seriously they take their job. And I apologize if you were sleeping and you just woke up to the phrase anal bleaching on a video about the Kardashev scale. My apologies. So a white hole is a hypothetical region of space-time which cannot be entered from the outside, although matter and light can escape from it. In this sense, it is the reverse of a black hole, but can be, which I was just defining a black hole, from which, of course, light and matter cannot escape if they have transgressed if they have crossed the threshold known as the accretion disk. Or sorry, it might not be the accretion disk, but once they have neared the black hole's proximity too close. White holes, though, let's get back to that, appear in the theory of eternal black holes, in addition to a black hole region in the future. Such a solution of the Einstein field equations has a white hole region in its past. However, this region does not exist for black holes that have formed through gravitational collapse, nor are there any known physical processes through which white holes could be formed. So they attract matter like any other mass, but objects falling towards them would never actually reach. Oh, event horizon. The white hole's event horizon. Oh man, this is getting very convoluted. It says, although objects falling towards a white hole would never actually reach the white hole's event horizon, what would they do? So, though, in parentheses here, though in the case of the maximally extended Schwarzschild solution discussed below, the white hole event horizon, the white hole's event horizon in the past becomes a black hole event horizon in the future. So any object falling towards it will eventually reach the black hole horizon. And so, due to relativity, a clock from a hypothetical objective perspective would slow down, would be ticking much, much slower. which means that a person's life span would be much longer in a high, very dense gravitational field. And yeah, maybe that's where I'll end this video. So I suppose what they're saying there is that the existence of a white hole, which would be in effect the opposite of a black hole. In trying to understand the dynamics of space-time and objects in relation to that phenomenon, you would have to consider the time dilation created from relativistic effects, like the immense gravity would, well, if it slows time the closer you get, then in effect objects, the closer they get to the white hole, which they cannot enter because it's a one-way exit sign, street, one-way road, exiting opposite direction. It's saying that the objects would be taking so long to eventually reach the white hole that by the time they got there, there's going to be, trillions of years in objective time, absolute time, fictional absolute time, that it would by then become a black hole. So, Jesus, I don't understand that. I mean, on the surface, it makes sense that of how how the time could be stretched out so long that eventually the objects do finally meet the white hole, but I don't understand how it converts to a black hole. But I won't waste too much time capturing the energy of gamma ray bursts is another theoretically possible power source for a highly advanced Type 3 galactic civilization. The emissions from quasars can be readily compared to those of small active galaxies and could provide a massive power source if collected. So, I'll leave you with this thought, is that Isaac Arthur proposed that the most advanced, Type 3 type civilizations that would be billions of years old could eventually, I guess trillions, because the scenario he played out on his channel, which, seriously, check it out if you're interested in this stuff, Isaac Arthur, so cool, is that if all the stars had diffused or dissolved and their life cycles had been spent, all their fusion is over, and the only essentially active celestial object after the universe has expanded to such a large degree that entire galaxies are no longer in sight of one another. They're well beyond each other's event horizon. Universal event horizon. And it gets to the point where even galaxies themselves are being ripped apart by the expansion of space, due to that unexplained expansion of space that Hubble discovered. They think that the last thing that civilizations would be able to tap into for energy would in fact be massive black holes at the centers of their respective galaxies. So, he proposed that, in fact, they would have, at that point, and it's literally unimaginable, but somehow he does. He proposes that they would have one scenario would be to create a simulation. This is called the simulation hypothesis, which I should look up before talking mad smack. Simulation hypothesis. Anyways, it's a simulated reality that would be run on the power of black holes, and due to the fact that computational power is a lot of times very tightly linked with temperature. The colder you could run computers at, the more efficient they would become, and essentially the ambient temperature of the universe at that point, at such a late stage, hundreds, maybe even trillions of years into the future, would be near absolute zero. So anything requiring heat dissipation would be very much inapt. We would find this scenario in the future of a near zero ambient universe temperature. Oh shoot. Well, my phone just died, but I guess I won't look into the camera anymore. But anyways, they were just saying that it was very cool that we could possibly be running in a simulation that would dilate time artificially so that mere seconds would last years, centuries, millennia for the participants of the simulation. And at that point, if there are multiple black holes light years apart, we could in fact how did the math work out for that? We could communicate across light years within seconds, within apparent seconds. It would be like how does that work? Shoot, I forgot. It made sense when he explained it. I can't seem to work it out right now though, but so if we could live, would it be the other way around? In real years, we could live mere seconds. Yeah, okay, I think that's what he did. He was saying we could slow down our perception of time so that a year in the real world, or in absolute observation, would become for us would be, we would be living, yeah, it would take seconds. artificial time to be stretched out to millions of years or billions of years artificially inside the simulation. But I guess that's I'll figure that out for another episode. Well, as rambly as this one was, I hope you guys enjoyed it. It's fun talking about futuristic scenarios like this, and I know there's a lot of literature out there about it, so I'm sorry I didn't prepare this as well as I should have, but at least it's gonna be a nice long episode. So with any luck, you are already very much asleep and very much relaxed. So I'm gonna leave it there and wish you guys a sweet farewell and a very, very good night. I really appreciate you sticking with me, and I wish you nothing but the best. I hope you have a great morning tomorrow. Hope you have a refreshing sleep.